Okay, so today I'll be showing you how to build this air compressor. This is a 3 horsepower compressor, puts it around 10 CFM, and it also has an integrated water chiller. So I'll show you how to make the water chiller too. So just to show you that this works, we're going to plug it in. It requires 240 volts, but we use a 110 plug, so because it's a little more easier to plug into extension cords and stuff. So let's plug it in. Just make sure our hands are clear from the pulleys. Yep, the pressure switch kicked in, turned it off. So a little hissing sound you might hear. There's a leak in one of the Teflon tape fittings. I think there's even a leak up here, so I'll have to come back and tighten everything. I just finished building this today. So here's how it works, all right? The first thing, what you're going to want to do is you're going to get the tank, okay? I prefer to get a brand new tank because you never know with a used tank you can have water damage. We don't want an explosion. This tank was $30 from Harbor Freight. I got it half off, so that's not that bad. So then once you get the tank, you're going to want to get a 2x12. You're going to want to bolt it to the top. Then what you're going to want to do is then this is your mounting platform. Also, this is unplugged. This is good, so I'm safe. So then what you're going to do is then you want to get some bolts. And the bolts or screws. I use screws here. And you're going to want to screw it into here. If it doesn't work, if this gets damaged or whatever, I will replace it with bolts, but I use screws because it's easier to fit little screwdriver in there than like a whole ratchet wrench or whatever to put the bolts in. So it was just a little out of convenience. I use screws to screw them in. I will guarantee though that this you can get away with a 2x12. On the store you have ones that are steel plate, but basically you have to compensate because the modulus of yield strength of a wood is 30 times less than steel. So wood is 30 times weaker than steel. For the same, if you had the same exact thing, like a wood block and a steel block of the exact same dimensions, subject to the same forces, the wood block would perform 30 times worse roughly, right? It'll deflect, it'll bend 30 times more. So the way you compensate for that is, your wood thing has to be much thicker than the steel one. And we know that the strength of a beam is proportional to its thickness cubed. So we take the cube root of 30, which is 3, which means that our wood member has to be 3 times taller or thicker, in this case, than our steel membrane to get the same strength roughly. So on the store I see them, 1/8 inch, 1/4 inch, which means the minimum has to be 3/4 inch for the wood equivalent. We oversized that. Obviously that's a little too thin for us, so we upgraded to 1.5 inches because it's a little better to oversize in that scenario. So once that's done, you're going to want to get your pump. I got this for $40 from Harbor Freight at half off. They had a clearance sale a while back. Then your motor. This is a 3 horsepower 10 CFM pump. This is a 5 horsepower 240 volt induction motor. The motor is oversized for the pump. I think it's good to oversize your motor for this compressor, this way it doesn't burn out. And also, this deep motor, I got a good deal on it for $100, so I might as well step up the motor, and then this allows me flexibility in the future. If I want to swap this pump to 5 horsepower, I could just easily do that without getting a new motor. So what you do is once you have that, you assemble it all, you screw it together, then you run a copper line. This is 20 feet of 3/8 inch copper, and you just run it in this bucket. I forgot to mention that you should use a cast iron pump. Make sure your pump's not aluminum because cast iron is much tougher material than aluminum. I think steels, irons, they're around 200 megapascal, aluminum 70 megapascal, so it's 3 times less strong roughly, aluminum. So get yourself an iron pump. Then what you want to do, you have 20 feet of this copper coil. It's 3-inch tube, 3/8 inch tube. The objective here, this is a water chiller, so it'll condense. Obviously, the higher the this compressor is taking in a lot of air. It's compressing it. So the relative humidity, there's a lot of water in here because 1 cubic feet of air, right, when it's compressed, it's only, let's say, a liter or something. So all that water evaporated in that 1 cubic feet of air will then be concentrated into this 1 liter. So the water is, when you have an air compressor, there's a lot of water in the air, in the line. So we want to remove that water because that will damage our air tools. So the way you remove the water is you condense it out. You cool this line very down to room temperature very fast. And if you do that, the water will condense out. So then the water will condense out, and gravity will make all the water go all the way down to the bottom of the coil to here. From here, it'll drain out into this tube. This tank has to be a little higher so gravity can push it down into this tube. And then once the water drains out into here, I'll raise this thing a little bit. The water will drop down to the bottom, and then the air will be able to go up. The water is going to fall on the bottom, and then you drain the water with this little valve. So once the water collects once a week, you just drain that out. The way the water chiller runs is you want to use copper because copper, the thermal conductivity copper is around 5 or 10 times larger than cast iron or iron for the iron pipe. So basically, that means that if I have 1 foot of copper with the same exact dimensions and thickness as 1 foot of steel, that copper will dissipate 5 or 10 times more heat. I think it's 500 watts per millikelvin for copper and 100 for steel, so that's where you get your 5 times. It might be 50 for steel, so which would that make it 10 times? I forget. So obviously, we could get away with much less material if we use a copper. So that's what we have. We have 20 feet of copper, and then you want it to be thin, because if you have 2 materials and one material is twice the thickness of the other, that one will transmit half as much heat. So it's a kind of an inverse relationship between your thickness and your heat dissipation, right? So the copper, when I see them use these steel pipes, that's not that good because this is 1/4 inch, 1/8 inch thick. This is, I don't know, like a 1/16 or something, or very thin. So it's around maybe 3 times, 4 times thinner than this. So it'll dissipate 4 times as much heat. And then also you want to fill it with water. Water is a very, it's much more thermally conductive than air. It's obviously, you're in a pool, right? You freeze, whereas when you're outside, not that bad, right? So this water will absorb all the heat dissipated by this motor. The way you want to size your water tank is this compressor pump is around 3 horsepower, which means that that's 2,000 watts. So if it's 50% efficient, that's 1,000 watts of heat. So you want to design the amount of water to withstand 1,000 watts of heat before it kind of boils. So you could calculate that because 4.184 joules is the specific heat of water. It comes out to be like a few gallons or a gallon or something. So we have I think this is like 4 gallons, more than enough water. And then we have a stainless steel pot because stainless steel is okay at dissipating heat, much better than plastic. I see a lot of people build their things with a plastic container. That's not good. You want to use stainless steel or some sort of metal to get that heat transfer into the atmosphere. So then that's basically how the water chiller works. I think I explained that very well. So then now once the air exits the water chiller, it goes into here, and we will step over to the other side. Okay, and then, so obviously we said that, the water droplets will fall to the bottom, and then we could drain that out, and the clean air will rise to the top, or it will just basically, go through the top, right? Not necessarily rise through it, and then it'll go back down into here. This is washing machine hose. It's cheap and flexible, so that's what you want to use. And then it goes to here. This is a leak. I have a Teflon. I'm missing Teflon there, so I have to patch that. And the air then goes here, and it goes right into the tank. And then the air for the tools go out here. This is our drain valve for the tank. Any water that this collection system misses has to be drained out, because otherwise it'll corrode the tank. So you just turn this valve, that'll drain that water out, and then the clean air goes up here and it goes to a little gauge, so we could see the gauge pressure. It goes to a little regulator for the tools to plug in, and then this is a cutoff switch, so it reads the pressure through this valve here, and when it's 120 psi, there's a contactor and it cuts power to this motor. This 5 horsepower motor. Additionally, you want a little check valve. This one broke. I think it was dead from AliExpress. I'll replace this eventually, but I found that it's not necessary for this compressor. The advantage of the check valve is, it keeps the air in the tank, so that when the motor is pumping, the motor doesn't have to pump against the tank pressure as much, or it's kind of like that. A little different, but at a high level, I assume that's kind of what it works like. So the air doesn't really flow backwards into the compressor. I think this compressor has like a built-in check valve or something. So I'm not gonna, for now, I'm in no hurry of replacing this. So that's pretty much, I think I covered everything. That's pretty much this compressor motor with the water chiller. If you have any questions, put them in the comments. The total cost for this was like $250, maybe $300 at the most. But this compressor, if we were to buy this in the store, you're talking like, $1,000 or something. And the water chiller, that's like $500. I mean, this water chiller cost me, like $40 to make, or $30. So this is much cheaper, and it performs relatively well. So this is how you do it, and then you just, for the bracket, so it sits on the floor, you just use some 2x4s and you just screw it in there for the legs. And make sure you oil your compressor. Just standard motor oil for a car is fine. So yeah, questions, put them in the comments. Thank you very much for your time. Have a good day.